Muy buenos días, estimados invitados especiales, autoridades administrativas, estudiantes, egresados y público en general. Mi nombre es Marco Tulio Canales, soy el jefe académico de Ingeniería Civil en Unitec de Tegucigalpa y tengo en esta ocasión el privilegio de dar a ustedes la más cordial bienvenida de parte de la Universidad Tecnológica Centroamericana, Unitec, y la Facultad de Ingeniería a la Semana Internacional de Ingeniería 2020. Este evento, celebrado anualmente por la Facultad de Ingeniería, tiene como propósito traer a discusión temas relevantes a nuestros tiempos y nuestra realidad actual, con la participación de invitados especiales que se desempeñan en el campo de las ingenierías. Niels Bohr, quien fue galardonado con el Premio Nobel de la Física en 1922 por sus contribuciones sobre la estructura atómica y la radiación, dijo: cada gran y profunda dificultad lleva en sí misma su propia solución. Nos obliga a adaptar nuestro pensamiento para encontrarlo. Tal como enunció proféticamente el Dr. Bohr hace casi 100 años, los grandes retos traen grandes adaptaciones. Es así como la Semana de Ingeniería tiene su primera iteración en formato virtual. Aprovechando las bondades de esta modalidad, tenemos preparados para ustedes una agenda realmente internacional, con conferencistas desde los diferentes rincones del mundo. Para dar inicio a nuestro programa, doy la gentil bienvenida al rector de la Universidad Tecnológica Centroamericana, el doctor Marlon Antonio Brevet Reyes.
Gracias, doctor Canales. Buenos días a todos y todas. Gracias por ser parte de esta semana de la Facultad de Ingeniería de Unitec a nivel nacional. Ojalá también estén conectados algunos graduados de las diferentes carreras de ingeniería. En primer lugar, decirles que felicito al equipo organizador de esta semana académica de la Facultad de Ingeniería porque han organizado una serie de conferencias, talleres y otros eventos que tocarán temas emergentes, temas que son tendencia y temas que darán mayores competencias a los estudiantes y graduados de Unitec. Decirles que las autoridades estamos tratando de seguir potenciando las ingenierías. Como habrán visto en el render que se les mostró, se está construyendo un nuevo edificio para la Facultad de Ingeniería en el campus de Tegucigalpa, el cual iba a estar listo en enero, pero por la pandemia estará listo en abril de 2021. Este año también y el año pasado se han reacreditado y acreditado 5 programas de ingeniería. A este día tenemos acreditados los programas de Ingeniería Industrial y de Sistemas, Ingeniería Civil, Ingeniería en Sistemas Computacionales, Ingeniería en Mecatrónica e Ingeniería en Telecomunicaciones y Electrónica. 5 programas de 7 que están acreditados con la Agencia Centroamericana de Acreditación de Arquitectura e Ingeniería. Igualmente, se reformó la carrera de Ingeniería en Biomédica y esta semana se va a compartir la nueva malla curricular. Y seguimos avanzando en Ingeniería en Energía. Esperamos que estas 2 carreras se acrediten en los próximos años. Igualmente, esta semana estaremos presentando ante todos los estudiantes de ingeniería y público en general nuestro nuevo programa de Ingeniería en Ciencia de Datos e Inteligencia Artificial, que ya fue aprobado para el campus de Unitec Tegucigalpa y próximamente será aprobado por el campus de Unitec San Pedro Sula. Obviamente que hay otras áreas donde necesitamos seguir creciendo. Una de ellas es el área de investigación y felicito a los estudiantes de los diferentes programas de ingeniería que han participado en congresos internacionales y algunos de ellos inclusive han ganado lugares en competencias estudiantiles. Sigamos avanzando, sigamos promoviendo la investigación en la formación universitaria y sigamos tratando de que más estudiantes participen en conferencias internacionales. Y en la tercera función de las universidades, que es vinculación, sé que en estos momentos es difícil de estar vinculando desde casa, pero me satisface ver las iniciativas que están saliendo donde estudiantes de ingeniería están dándole tutorías a niños y jóvenes a través de la tecnología, así como están tomando clases con nuestros docentes, están ellos dando clases con la teledocencia. Creo que la ingeniería en Honduras es un área que necesita crecer en función de más estudiantes. And now I'm going to switch to English since I know that the next topic is very interesting for women. I would like to thank our speaker, Dr. Ramla Qureshi. She's a faculty member at State University of New York. And Dr. Qureshi, I would like to let you know that in Honduras, we are making great efforts to recruit more students in engineering, and we need more women in engineering. So your talk today is a keynote speech, and I hope that it makes us work on recruiting efforts to attract more women and to connect more with high school students. I know that engineering is an area that is very important for the development of Honduras. And post-pandemics, I think that we need to have more engineers. And I am really grateful for all the work that our graduates are doing in this pandemic. I thank you again, Dr. Qureshi, for your contribution. And I look forward to listening to your conference. And I welcome everybody to this academic week of the engineering faculty. Thank you very much.
Agradecemos al Dr. Marlon Brevé, rector de Unitec, por sus inspiradoras palabras. Seguidamente, tenemos la participación de Ramla Qureshi. La ingeniera Qureshi es una ingeniera científica pakistaní quien se desempeña en varias de las ramas más avanzadas en el amplio espectro de la ingeniería civil. Ella estará compartiendo su experiencia académica y profesional con nosotros en el idioma inglés. Ramla was born in Karachi, Pakistan, on November 11, 1990, as the middle sibling of the 5 children of Dr. Sadid and Karim Qureshi. Upon completion of her high school education, Ramla moved to the capital, Islamabad, in order to pursue her studies in civil engineering at the National University of Sciences and Technology, where she obtained her bachelor's degree in civil engineering. Her undergraduate experience as a woman at the top of her class in a broadly male-dominated field of study inspired in her the desire to level the playing field by motivating other young women to realize their potentials in STEM fields. She founded Women Engineers Pakistan in those early years with the broad ideals that encompassed the Gender Equality Initiative. In parallel to her enterprise, she continued to pursue specialized education and was awarded a Fulbright scholarship to continue her studies in structural and earthquake engineering at the University at Buffalo, where she obtained a Master's of Science degree in civil engineering under the guidance of Dr. Michel Bruno. Following the completion of her MSc degree, she continued to pursue a PhD, developing the thesis, Advancing Performance-Based Fire Engineering through Systematic Testing and Analysis of Structural Systems. Ramla is currently part of the Khorasani Research Group at the Department of Civil, Structural, and Environmental Engineering at University at Buffalo, the State University of New York. During her tenure there, she has obtained various honors and awards for her academic and entrepreneurial achievements, and some of these include the Chair's Recognition Award, the Professional Development Award, the Leaders in Excellence Award, and she had the honor of being the University of Buffalo School of Engineering and Applied Sciences representative to the House of U.S. Representatives in the 6th Annual American Association for the Advancement of Sciences, catalyzing advocacy for science and engineering workshop in Washington, D.C. Her research has been published various times in important journals and periodicals in her field of expertise and enterprise, such as the Journal of Structural Engineering, the Journal of Structural Fire Engineering, the World Bank blogs, and the News International in Pakistan. Her work has been accepted internationally at conferences in Canada, Ireland, Australia, and of course, the United States of America. For her entrepreneurial and academic distinctions, she has been invited to talks and conferences in India, Nepal, the United States, and most recently, Honduras. Ramla has been the proud recipient of numerous grants and fellowships for her achievements, including the American Association of University Women Doctoral Fellowship, the Mark Diamond Research Fund PhD Research Grant, the Rajiv Circle Fellowship for Social Entrepreneurship in South Asia, and of course, the Fulbright Scholarship Award, through which I had the distinguished honor of making her professional acquaintance. Ramla's list of accomplishments and distinctions goes on and on. So before I prolong this introduction too far and take up time from our exciting agenda, it's a privilege to kindly present to you Ramla Qureshi.
Hi, I'm really excited to be here. Um, Let me see if, yeah, there we go. Here's my screen as well. So today I will be talking about my initiative for women engineers, especially in Pakistan, but also globally, and also about my research, my PhD research in resilience of communities and civil infrastructure against extreme hazards. But before we get into that, I would like to talk about a little bit about my own introduction. Uh, Growing up, like Marco right now mentioned, we were five sisters and we were quite a handful. And our mom bought us books that were about how things work and robotics and amazing places in the world. And that sort of inculcated this immense desire to learn within the five of us. Growing up, we didn't realize that there was some sort of gender dynamics at play because we were five sisters. So we didn't have any sort of comparative threshold. But as soon as I entered into engineering in my undergrad, I realized that I was one of the minorities in the classroom. And that came as quite a shock that people would doubt my abilities as a scientist or as an intellectual person just because of my gender. This obviously was something I had not been prepared for growing up in a household of all women. There were, like I said, absolutely no gender dynamics at play. So out of sitting there in that civil engineering undergraduate classroom, I clearly remember that there was this professor who asked me, "What are you doing here? This is a very male dominated field, and you will probably not feel very comfortable there." And I tell this to everyone that I speak to, that before I could stop myself, I responded just out of instinct that, you know what, that's the mentality that we're here to change. And, and the rest is just history. Today, I am a civil engineer. I am researching in multi-hazard structural resilience coming from Pakistan, which is sitting right on top of a very active tectonic fault. We get a lot of very dangerous earthquakes. Just a couple of days ago, my hometown of Karachi got this immense flooding as well. And you can see that these are the things that made me who I am and made me interested into multi-hazard research. Because of that, I was able to get a Fulbright scholarship and come to the US to pursue my higher education and obtain a master's. After that, now I am a PhD researcher at the State University of New York at Buffalo, New York. I am also the proud recipient of the American Association for University Women Doctoral Fellowship. But see, I was thinking that this is just me who had to go through this, or this is just Pakistan that isn't very welcoming to women, especially in STEM fields. But that is evidently not the case. We know that based on numerous surveys, one of which is the Future of Jobs survey by the World Economic Forum, that of all the engineers worldwide, there are only 11% that are women. That is just astounding to me. So if we want, the world is right now in this amazing technical revolution, and we've left almost half the population behind. And that just doesn't add up, right? Also, of these 11% women in STEM fields, we know that STEM fields these days, like I said, we're in the middle of a technical revolution. STEM fields are the highest paying jobs, and yet um, for every dollar that a man earns, women earn 28% less, which is, again, very ironic to me because I never realized that gender had anything to do with your brain, so or your capability as an engineer. So it seems that we are facing impediments because of culture and because we're not being able to take this disparity head on. So in my country, in Pakistan, there was a survey called the National Education Assessment, and they found out that up until grade 8th, girls were outperforming boys in not just in science subject, but in everything, right? But if you look at the amount of engineers or the technologists in the country, that's just 10% are women. So there's definitely something that happens right after middle school um, that is stopping our girls into pursuing STEM fields. My solution to that, sorry, before I go there, I wanted to bring in some. Like I said, I was thinking this is happening just in Pakistan. However, if you look at globally, so for example, even here in the US, of all the science and engineering positions, so this is coming from a study in 2015, just 2% were Latina women, right? And that doesn't make any sense to me, because now this is a double minority. You are Latina, and you are, again, you're a woman as well. So these are actually dire facts that we have. In 2020, we are still figuring this out rather than taking this head on. And for me, this is just not on. I mean, I've seen some incredible women in science and engineering. Some of these women, I'm sure you will be able to recognize here as well. We have Marie Curie, we have Katherine Johnson, we have we have Mariam Mirzakhani, or from my own country, Nargis Mawalwala, who was just a couple of weeks ago nominated as the Dean of Science at MIT. So there's obviously nothing stopping these women back, other than perhaps these cultural impediments that we have. These are our role models spreading from Europe, from Pakistan, from Iran. Maryam Mirzakhani came from Iran, where we expect that it's extremely difficult for women to progress, again in Pakistan as well. But since we have these role models, we know it's possible. We know that if the circumstances are right, women can achieve just as much, if not more, than men in science and technology as well. My solution to enabling the participation of women in STEM fields is my company called Women Engineers Pakistan. We work on three major focus groups. We start at the feeding of the pipeline by motivating high school and middle school students. Now, what of the 7 years of on-ground work that I've done in Pakistan, I've noticed that young girls, especially when they're transitioning from children to pubescent adults or adolescent adults, they start absorbing these cultural hindrances, and we also somehow subconsciously are telling them, you're not good enough, you're not good enough, you probably should not deal with equipment, it's okay, let me handle the math, you just do the arts things, right? Or how come you're so good at math? Women are not that good at math. These are these implicit biases that we are telling our young girls from a very young age. So what we do from Women Engineers Pakistan is that we bring the science back into the hands of young girls. We give them equipment and we tell them, break it, it's fine. So these are very cheap, let's say paper microscopes, or just imagine that you have a paper plane, and with that paper plane, you can teach young girls about drag force and about trigonometry and about projectile motion and all of these different things in science that are dry if you just read them in a book, but imagine playing a game with it. So we inculcate something called game-based learning, where we have curated whole modules of games built around maths and physics and biology as well, chemistry as well. The idea, again, is not to teach rocket science within one session. The idea is to let girls feel that they belong here, that they belong within the STEM fields. And when you make it playful, when you inculcate games in it, you make sure that young girls are in touch with how exciting science can be. And you will not imagine the drastic changes we see in a classroom of timid, shy girls and before we start our session and after we start a session. These are these loud women making mistakes, asking questions, so engulfed in understanding science that they forget that they were supposed to be scared of maths and physics. Now, this is, like I said, the start of the STEM pipeline, the motivation part. Then we have the second focus group, which are the undergraduate women. These are girls that we focus more on. We give them, state-of-the-art software skills, soft skills as well about how to negotiate jobs, how to negotiate salaries, how to navigate through workplace scenarios, and again to let go of the fear that they don't belong here. I hate to admit it, but my country is still very much a patriarchal society, and it's constantly a reminder for women that the male dominated fields are not for us. Again and again, we have this thing called prove it again syndrome, where every day you have to prove that I am capable. Every day you have to prove that. So it results in burnout, right? So we enable our young girls to be so self-motivated that they feel like it's okay to make mistakes because that's how we learn. So we are trying to diminish the hesitance and we're trying to exaggerate the excitement of being in STEM fields. Now, we've motivated the girls and we've recruited them into undergraduate science fields as well. But what happens when they graduate and they enter the work field and again they're met with friction? That is where our focus group of professional women comes in. We work a lot in advocacy domains, so we work with organizations such as the World Bank, such as multiple development organizations, the GIZ, the USAID, to conduct seminars, to conduct trainings, again, like I said, about how to negotiate a promotion, about why should companies have daycare services, why. So, for example, some places in Pakistan would still not have something as simple as female toilets, which you would expect is a basic human right. But somehow women have been absent from STEM workplaces for so long that it never occurred to anyone that women would need a separate restroom. And I myself am an example of having to let go of a wonderful job offer because the office did not have a female restroom, and I did not feel it dignifiable to go to a, a to use the restroom at a KFC next door or something like that. So there's a whole plethora of work that we do through these three focus groups that I said. Our agenda, let me summarize, is to motivate young girls towards STEM field, like I said, through game-based learning approaches. We want to increase the representation of Pakistani women in STEM fields. So we showcase relevant role models just so that young women know that they're not the only one, right? Being an only one in a classroom or in a workplace is tiring. You have to maintain your advocacy or your agency every single day. And that is not very productive as well. So if we present young women with role models, we can push the fact that you can be it if you see it, right? So and when I say relatable young models, I mean Pakistani women, because I can look at Marie Curie, but I would think that, yeah, maybe it was easy for her. She was in Europe. Whereas I wouldn't even think she was in war-stricken Europe or something like that, just because maybe she doesn't look like me or she isn't from my era. So it's very important to have relatable, relevant role models for women and for young girls as well. Then we provide STEM career counseling. So let me give you my own personal example. I had no idea what civil engineering entailed, and I had heard of it, so I went into it. I don't regret it a single bit because I absolutely came to fall in love in it. But I mean, imagine what if I had known I could have been an astrophysicist, or I could have been a nuclear physicist, or something uh, else that I still am a little bit scared of. So we provide that service that perhaps we didn't have, and we share our learning through these STEM fields that we gain to younger girls and women as well. We also talk to people. So, for example, women who had to let go of the work field for some reason. They got pregnant, they got married, they had to raise a family, or they had some other circumstances because of which they weren't able to follow through with their career. So we provide them STEM returnship counseling as well. We promote the liaison between industry and academia. So we conduct we link with people with jobs and internships. We're also in the process of conducting a job fair right now. We provide access to recruiters to a very gender sensitive, STEM focused talent pool. And that is what gives us the edge in the Pakistani HR market as well, because we're very, very focused. Again, we picked up a niche, and that's something that worked out for us. And lastly, our agenda includes that we determine the essential needs of professional women, and we urge policymakers to provide these women with ease and convenience so that they can focus on their career rather than on the cultural and traditional impediments that create hurdles in their progress. So far, we are in 8 cities across the country. We have presence in over 15 university campuses. We have almost 10 campus ambassadors per campus, and we also have about 700 student members, and we're a community of over 2,000 professional women. Like I said, we're very focused. Our focused online reach is over 20,000 people 20,000 women in STEM who follow and learn and grow with us. And we have so far conducted outreach to over 4,000 students, not just in Pakistan, but in Nepal and in the US as well. We have been very fortunate to have partnered with some very amazing organizations throughout our journey. Some of these include the World Bank, like I said, Google developers, the UNDP. We are currently working with, again, other women-focused organizations in Pakistan, such as Women in Energy, Women in Tech, and also Code Girls. Having said that, we have a whole plethora of information available on our online portals digitally, and please feel free to contact us through our website, and please follow us on Facebook and Twitter, and we would be very, very happy to get in touch with you if you have any questions or concerns. Now, having said that, here is the other half of who I am, which is a PhD researcher. And all that I do for Women Engineers Pakistan is because so that other women like myself can step into the play to the work field and make actual tangible changes to the world as we know it. Like I said, my own country is ridden with multiple hazards. We had various natural and man-made hazards over the last 10, 15 years as I was growing up, and as I was inculcating these various global changes happening around myself. And that is why I decided that I wanted to step into understanding what I can do to save the communities from such hazards. We have this saying in civil engineering that earthquakes don't kill people, buildings do. And that is why I wanted to research how I can create more resilient structures that, excuse me, that people in my country would no longer have to suffer. Back in 2005, there was a massive earthquake in Kashmir in Pakistan, which unfortunately led to the demise of over 80,000 people, and over 100,000 people were displaced. And that left a very scarring mark on my brain, which um, made me feel like there was something that we could do. And that is why I want to present my research to you, and hopefully you can grow from it as well. Like it was mentioned in my introduction, I am part of the Khorasani research group. My professor, Dr. Ilhami Khorasani, works on structural and community resilience. So she specializes in fire following earthquakes. She works for different sort of infrastructure projects, including buildings, including networks, including tunnels. I am one of her her four PhD students, or PhD researchers who work and learn from her, and we all are situated at the Department of Civil, Structural, and Environmental Engineering at the University at Buffalo. Now, some of the extreme hazards, like I mentioned, include earthquakes. This is a view of the damaged hotel. I think it's called Ancentro in Mexico in September 8th, 2017. As you can see, there's a complete failure of the entire building. And if at all we as engineers are prepared, we may be able to create buildings that are able to resist, or at least give us time to evacuate. So whatever performance objective we want, if it's life safety, if it's functionality, we should be able to design structures that are able to give us those performance objectives. Other extreme hazards include floods, like I mentioned a couple of weeks, sorry, just last week, there were immense monsoon rains in my city. This is a photo from Karachi a couple of days ago. And you can see that it's just a mess. People are just completely unable to get to places. There were Karachi is the largest city in Pakistan, and imagine that the largest metropolis of a country is completely at a standstill because there are no redundancies in resilience for this community to still function despite an extreme hazard. And then, of course, you're also familiar with fires and wildfires. This is a photo from a forest fire near Yosemite National Park in 2013. To this day, we have bushfires in Australia. We have even a couple of weeks ago, we have wildfires raging in California here in the US. And then there are man-made hazards. So all of you, I'm sure, have heard of the extreme explosion that happened in Beirut in Lebanon last month. It was an extremely jarring sight. And I personally, I couldn't sleep that night when I saw that, because it was just crazy how much the level of destruction was. And we as engineers have this, we should make it our job to learn from these hazards and build so that we can protect our citizens from such scenarios. So let me give you a couple of statistics about fire. So globally, in the past 2 decades, there have been over 86 million fire accidents, and we've lost over 1 million lives because of that. So obviously that results in a lot of money lost as well. So we have about $900 billion that we lost with just annually, just 1 year. It's 1% of the entire global GDP we're losing on fire destructions. And on average, we have about 45,000 people passing away globally. So this is definitely an extreme hazard that we need to increase our research in. In the developed world, USA is unfortunately at the very top of the list in both fire-related deaths and fire incidents as well. and approximately $300 billion are lost annually in the US only because of fire incidents. Now, when I say that we need resilience of communities and networks, how do we gain data to have this sort to build urban resilience? So based on the definition from the Rockefeller Foundation, urban resilience is the capacity of individuals, communities, institutions, and businesses and systems within a city that they can survive, adapt, and grow no matter what kind of chronic stresses and shocks that they experience. So that implies that urban resilience has to work with, disaster reduction and disaster mitigation. Like I said, survive, adapt, and grow. So how can data help us bring resilience to urban environments? Now, cities are inherently vulnerable because unlike people, cities and systems can't really move. They are immobile. So they need to be, again, like I said, they need to be redundant. And we need to know that as civil engineers, we can't pigeonhole ourselves into just talking about engineering materials, for example, or just structures. We need to know how we interact with the ecosystems around us and how the ecosystems interact with us. So urban interactions, for example, you've probably heard of fracking, which is illegal in the US now, hopefully, and it causes earthquakes as well. Or like we talked about the Beirut explosion, that was a huge uh, effect on of urban settings, of community settings to the ecosystem in general. Then again, fires and wildfires. Wildfires specifically are getting more and more hazardous because we've started pushing the boundaries of forestation, and we've started manually suppressing what is a natural phenomenon of wildfires. So now the wildfires that we are getting are, let's say, 10 times as dangerous as they should have been. And we aren't able to get them under control as soon as we would have liked. And most of this is happening because of human development and human interaction and human interference with ecosystems. So some of the important things to remember as we go through this presentation is the interaction of, transportation networks, bridges and roadways. Again, for fires, especially water and municipal networks are very, very important. Then for any hazard, you need to have power and energy networks. So for example, in Pakistan, in Karachi, when the floods came, there still is power shortage and power cuts across the city for over 42 hours. And that is just not right, because then you have people suffering. They are not able to communicate and contact with the rest of the world or even call rescue agencies. And that is why systematic redundancies are very important. Um, as we go through this presentation, you will understand that access to data can help us support sustainable research. So let's dive a little bit deeper into how urban systems interact with ecological systems. So we know that so this is a map of California, state in New York, and we know that California's so right now this is a map presented by one of my colleagues, and he's plotted the historical data of past fires from the last 9 years in all of California's counties, and you can see that there is some data missing. This missing data is problematic, right? Because this had to be, imagine that there is climate change that is, it's exacerbating the chance of bigger wildfires in California. But if we don't have data, we have to extrapolate, and we don't know exactly the amount of confidence that we have in this data as well. So because we have uncertainty, that is why we need to have all these probabilistic and stochastic models built to understand how this data interacts with ecological systems. So to understand the fire spread, we need data on ground elevation and topography. What are the average wind speeds? We need to know if people are constructing with wood, with concrete, with brick. We need to know if there is plantation around these communities, because for fire branding and again fuel. What are the fire suppression resources, and what are the fire rescue water networks? So we need data on all of this. And once we have this, we can overlay this topology. So my colleague did this. He overlaid the topology data of California with climate reanalysis models, and he was able to get this predominant direction of winds, and now he understands how ignition models can work, because we need to know if a fire does happen, what way would it predominantly affect communities. So that is one way we can prepare for disasters that may be coming our way. So for example, this is a case study of Tubbs Fire. This is California's most destructive wildfire that destroyed at least 5,000 homes and killed over 22 people. It's just horrendous when you read about it. Communities were just completely incinerated. And even now, communities are now being exposed to faster spreading wildfires in the recent years, and we need integrative urban fire spread models. So we will take, for example, the Fountain Grove community here, which, if you can see, I am pointing this out as well. This is a very focused community that we're looking at, and we're going to apply a fire spread model and understand how this worked. So if we have to predict fire spread, we need the data inputs of building footprints, and like I said, again, combustible materials, if we're using them. What is the construction type? Is it single story, double story? If it's double story and there's a tree on fire, there's more probability that will have fire branding of this sort. And again, we need to know the basic physics of radiation and direct flame contact and things of that sort. So my colleague was able to gather all of this data for the Fountain Grove community, and you will see that he plotted it with respect to time. This is now a fire line that advances based on three primary processes, which are thermal radiation, direct flame contact, and fire brands. And at this point, a model does not exist that would integrate these three mechanisms into fire spread for wildfire and urban interaction communities. So any predictions right now are based on actual events. So we are creating models, studying what happened in history. So this is, like I said, Tubbs Fire happened in California, and we're trying to learn from that as well. So we learned about how a fire spreads in a community from, let's say, it was a wildfire, but because we were building, now it is spreading through a community. What happens within that community? There is a fire, is like, say, a house or a residential building is on fire. If it is a post-earthquake fire, then there is debris on the road. That means that roadway accessibility is blocked. If there is water availability, we need to know if the electric network is working. We need to know if the transportation network is working. So all of these networks are directly related with how we interact with hazards and how we understand risk that these hazards pose to our communities. So we need to know all these different layers of networks that a city interacts with, right? So some of these networks exist in community data. For example, certain parts of a community are more populated and more dense than other parts of the community. Certain parts are were built, let's say, ages ago, and we don't have as much space for a big, broad fire truck to enter. We need to know census tract data. So, for example, again, like census tract data will let us know if what is the age group of people? Are they agile enough to evacuate? Then we need to know the hazard map data, such as what I showed you based on the climate analysis models that my colleague made. So we need to have transportation networks, like I mentioned here in the previous slide as well, that what is the road and bridge functionality and accessibility. And we also need to know the water and electric networks and how they function. So these are all the GIS layers of interaction with urban data that we need to understand, and we need to know how all these networks come together to build a city and how we can improve on these networks to create a more resilient city. So let me quickly run you through a case study. This is a model city in the US. And let's say there is a fire at 3 different buildings. So for example, if you haven't, maybe you can read up about the 2011 Japan earthquake, which led to multiple ignitions, and the destruction that happened was mostly because of the ignitions and not because of the earthquake. So similarly, in our models city here, there is this fire. As you can see, it was a small dot and now it's spreading. And how do we figure out that the same underlying water data? So all of these node points are, so there are 2 pumps in this city, and then they have this separate community pump as well. And we need to know if all the node points that these main city water pumps provide water to have sufficient or insufficient pressure. So again, data collection, right? And then the last layer for this purpose, for example, now there are 3 fires here. I need to know if there is water, and I need to know if my what is the quickest possible access that my fire truck would have from the fire station. So if this is the fire station, the fire engine route, the quickest fire engine routes are now highlighted. Again, these are live models that you're looking at. As you can see, that we animated them for you for this presentation, but at the click of a button, we are able to manipulate these based on the data research that we did and apply it to this case study. But what happens, for example, if there's an earthquake as well, and I have bridges in my in my transportation network? I need to understand how functional are my bridges, right? So this right now, my colleague has created, again, a data-based risk-informed software tool that takes into account all the properties of this transportation network, right? Or if it's concrete, what is the kind of earthquake that happened? And quickly, he gets fragility curves that give you a probability of reaching or exceeding a specific damage state under earthquake excitation. And like, no, I want you to know that all of this is a model, and models are only as good as the data you provide them. But again, at the end of the day, they are just models. They can never be exact reality. Having said that, we're engineers. We don't need to have exact realities. We need to have something that works, that gives us time, and that gives us understanding of how we can save lives and property, right? So fragility curves give you this sort of a prediction of potential damage during a design earthquake or a maximum earthquake. So that is also one way we can plot the limitation of different networks across the city, not just transportation networks. We can have fragilities for water and electric networks as well. But as civil engineers, of course, we are more concerned about the infrastructure around the city. Now, moving on, we said that, okay, we talked about city level, sorry, we talked about wildlands interaction with cities. Then we talked about cities, and now from communities and cities to zooming in into buildings, right? So we need to underpin the uncertainties that we have in our design methods. So, for example, if there is a fire that has started in a building, what are the fire dynamics, right? Is it a paper fire? Was this a storage of chemicals? Is it a chemical fire? Is it a petroleum fire? These are the uncertainties that we need to know. So in my country, for example, if there is a residential building and sometimes it's being used as storage, so it was never really designed for storage, and now it's being used that way. So these are uncertainties that we need to know of even before a building has been designed. Again, what is the structural strength post-fire and during fire as well? So we need to know, we need to establish this sort of understanding of uncertainties and probabilities of failure based on our material properties as well. Then what are the fuel uncertainties? Like I said, in some certain times, a building was supposed to be a residential building and then it's being used as storage or as a parking lot, or that happens in our countries, and that is something that we need to know, that there are uncertainties because of fuel. And also, what is the global structural behavior? Right now you can see that only one compartment is on fire, but how does the increasing stresses on this level interact with how the rest of the building behaves? So zooming more into that now from a data perspective, when I say that we have fuel uncertainties, so recently my research group conducted this fuel load survey for the NFPA, which my professor and a couple of her students conducted very thoroughly for office buildings, where it was a start to understanding that the fuel load data that we have for various building occupancies is outdated, right? So for example, in Silicon Valley, you have wires upon wires upon wires, and they're going to interact very differently based on the fire data that we have for offices, right? The office data for fire that we have would assume that there's a lot of wood cabinets and files and papers, but perhaps that is no longer true. So my supervisor, she used machine vision, right? So what would happen is that you would snap photos of different uh, things in an office, so for example, a chair, and then she would use this machine vision to take the properties from, let's say, so I mean, all of you can try this in search by image on Google. You can very readily get results for an image that you pick. So why don't we make use of technology that we already have and build a better online database so that we can mine this data and understand what is the caloric value, the fuel load that we expect. So for example, now plastic and metal would burn very differently. Foam would burn very differently. All of these would have very different heat release rates. And these are very important to know if we expect a compartment fire to get out of hand. So this is a four-step method that was developed that comprised digital inventory, data organization, then item matching through machine vision, and fuel load estimation. And then there is, even like I said, plastic would burn differently than metal. So as we zoom even more, so we zoomed into buildings, and then we zoomed into fuel load uncertainties, and then we zoom into construction materials. So if you see that in construction materials, for example, we have concrete and steel as the most common construction materials. So what we did was that we wanted to know what is the retained strength of concrete and steel, because you all know that stiffness of a structure would degrade as it burns. But when we're designing it, we keep a constant value at room temperatures. That is no longer going to be the case when the building is at 600 degrees Celsius. So we collected data, immense amounts of data from different experiments that had been done to understand the fire properties of construction materials, and we created stochastic models to understand how these models would give us a variability, right? An extreme load, extreme case scenario, and a lower quantile as well. And then we need to know what are the uncertainties and material properties that we expect, right? So again, let me reiterate, these are just models, but data and models give us a better vision of how the world, how the universe around us interacts with various different stimuli like fire and earthquake and things of that sort. So, having said that, I will wrap up into what we talked about and what my research comprises of. We talked about how data and resilience in a regional perspective will help us build better communities. And we saw the interaction of a hazard on a community scale, on a building scale, on a compartmentalization, and on material level as well. Now, as you would know, I talked at the start of the presentation, I talked about how access to data can help us get better research and help us get prepared. So there's this thing called citizen science, where, so for example, citizens, there is a, by the USGS, excuse me, it's called USGS Earthquake Experience. So it's called Did You Feel It? Now, this is not scientific data, but it's about, okay, people 10 kilometers or 50 kilometers or 100 kilometers away felt the impact of this earthquake. This does not mean that we would rely on the feelings of people, but it gives us a general sense of how the earthquake and how the hazard, fire as well, for example, touched people. So I'm sure you all use Facebook, and you've seen that there is this, mark yourself as safe community data on Facebook as well. And that lets you know the extent of community that any hazard reached. Then we are now, as scientists, looking into the Internet of Things and smart cities. And of course, there are various levels of politics involved in data collection from citizens as well. But this science has immense potential, and we as engineers and scientists need to be able to bifurcate politics and actually make good use of data science that we have. And then we can have people teaching initiatives as well. We can have an exchange of information with stakeholders. That is something that has been proven to be very, very effective, and all stakeholders know and understand what to expect in case of problems. So we saw that in Christchurch earthquakes, that people, were kept updated with the hazard levels, and that is why they all had insurance, right? So that is something that we need to communicate as scientists to communities that may not necessarily be engineers and scientists. And we need smart appliances and applications for real-time response and evacuation as well. Thank you so much for listening to me. Please feel free to reach out to me for my research. You can get in touch with me on my university email, which is at buffalo.edu. And for my STEM and gender initiatives, please get in touch with me at ramla.qureshi@womenengineers.pk. Thank you so much. Please let me know if you have any questions.
All right. Thank you, Ramla, for that heightening and tremendously interesting presentation. We have a couple of questions that the viewers have asked. We have a question from Isaac. Isaac asks, do you plan to globalize your program to third countries?
Yes. So I already am writing proposals to conduct similar research in Pakistan. Um, we are. I know that I mentioned that US is at the top of the list for the developed world, but Pakistan and India are top of the list for the not so developed world in fire cases as well. Trouble is that back home, um, structures and systems are not as streamlined as we would want them to be. So it takes some time, but we're pushing it and we are writing grants and we're writing proposals. So, yes, I will obviously start from home ground. That way I have home ground advantage. And maybe we can learn more local data from what we understand from Pakistan.
Awesome. We have another question. Where do you see women engineers Pakistan in the future?
So we've been active for 7 years and we've completely taken over Pakistan as a movement, which was just amazing to see that this initiative had so much potential. So many women felt that this was something that they needed. They needed representation, they needed vocalization, they needed advocacy. So just a couple of years ago, we were able to make it into Peshawar and Quetta, which are traditionally difficult areas for gender-sensitive interventions. When we went to Nepal, the 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 response were just as amazing because it's interesting to see that in that region, culture is very, very similar. And I still remember that there was this in 2015, I went to this conference to talk about women engineers Pakistan in Nashville, and I was later I met with a young woman from India who had tears in her eyes when she said that she had no idea that there were other people, other women who were going through the same thing. So that really rang a bell for me that I need to expand this program from Pakistan to neighboring countries and hopefully worldwide as well. In the next few years, we will be starting a digital training institute where we will no longer be hampered by man-made boundaries. Hopefully, with the help of global digitization, we will be able to tap into more countries and get access to women worldwide because we really truly believe in communities and building those communities. My hope is that other people will replicate what I've done with Women Engineers Pakistan um, all over the globe. Because, as I've said before in previous interviews as well, that my dream is that Women Engineers Pakistan be put out of business. My dream is that there is no need for Women Engineers Pakistan. I know that that's very ambitious and there is a long way to go, but hopefully in my lifetime, we will be able to see that globally, women and men together can progress humanity.
That's a great answer. Um, Now, and here's another interesting question. If you could text yourself advice through time, what would you tell your younger self as she was beginning Women Engineers Pakistan?
I so many things. Um, I would definitely tell that 20-year-old girl to not be scared and just don't take no as an answer because we are so culturally tuned to take no as an answer, that we tell ourselves no even before we ask. So I would tell Ramla, who was starting Women Engineers Pakistan, to just roll with it. Make mistakes, it's fine. Because we learn when we take risks.
I agree completely with that. Let's see if we have another one. Yes, we have another question here. Someone asking, how can I start something like WEP in Honduras? Or would you consider having a Honduran chapter, which is similar to the first question?
Why not? Absolutely. I mean, that is, like I said, my dream, to reach globally. So if you wish to start something similar, just start. So I started from a single Facebook page, which is a very funny story because I was bored and I wanted to just express the frustration I was feeling in my workspace. So I started this Facebook page and named it Women Engineers Pakistan, and the intention was that I would share articles and information from the rest of the world for Pakistan. And within weeks, it snowballed. And a couple of months into that page, we got contacted by the US Embassy that they have an engineer from NASA coming over and they wanted to meet my team. And I didn't have any team, it was just me. So I still remember I had to beg my colleagues to pretend to be the team of Women Engineers Pakistan just so that we could go meet this amazing engineer from NASA. And that literally changed my life. And I realized I need to build this. If you wish to start a WEP chapter in Honduras, please get in touch. We have all the modules ready, so you won't have to start from scratch. We can share our modules with you. We can share our learning with you, and we can run multiple pilots through your help. And we can see where it goes. So please do feel free to reach out to me.
Great. We have another question from the audience. Advocate asks, which would you say are the 3 biggest discoveries you have made with your study about building resiliency?
Very good question. So I would say that I used to think that engineers know everything. And I used to think that if it's in the code, that's like Bible, right? And as I started reading and researching about buildings, I realized that we were working with things that were good enough. And they were good enough. So for example, for earthquakes, there's a lot of active research. So a lot of the data and the models that we have are as close to accurate as you can imagine for current trends. But for fire, for example, we don't really know that much. And we've been relying on data that was collected in the 70s. So that to me was news because I was in depression that, oh my God, all these columns in the buildings are not safe. And then my supervisor had to calm me down that it's okay, buildings have redundancies and they have fire stoppers and they have active fire suppression and they have, firefighters, it's fine. But it really came as a shock to me that a lot of work needs updating. So when you talk about building resiliency, it's not something written in stone. We have to keep updating, which is why the idea of performance-based design is very, very relevant, because you create models and then you create a inflow of data through those models, and that gives you a standard deviation of risk. And then you as an engineer can decide what level of performance you want from the building. I would say another very important discovery that I made was that how amazingly math translates everything in the universe. So I used to be very scared of math, and now I cannot imagine what I would do without my understanding and knowledge of math and building resiliency needs everything goes back to math. So make math your friend, and math will never disappoint. Marco, you are mute.
Sorry about that. We have a question. Investigation or research is important for knowing the security systems in a project. How important? I believe the question is, how important is research for knowing the security systems in a project?
Very much so. But most of the times, what we do in academia is very, very detailed, because we are investigating what would happen if I create a ping in the system that was working smoothly, right? But when we are constructing or when we're engineering, there are thousands of different things that go wrong and don't go as controlled as we have in a lab environment, for example. So having a threshold of what may go wrong in any project is very important, I would say, and research can help give that threshold. Whereas when you are in construction projects, you are racing against time, so you don't have time to sit and conduct a PhD on that project. So you definitely need to integrate faster setups, which is why the Khorasani Research Group is very, very inclined to create industry-ready software tools. Like I showed, my colleague created a software tool for rapid population of bridge fragility functions. Something of that sort can give access to risk-informed practices in any project.
Okay, and we have one final question from the audience. Juan Carlos is asking, how can someone begin to apply all the hazard studies in a country where the data is not completely readily available?
Mm-hmm. It's not just Honduras. Let me clarify that Pakistan is exactly that way. We only now have access to some data coming from rescue agencies. A lot of that happened after, unfortunately, a disaster had to happen for Pakistan to start collecting data. A good starting space would be to know the census tract data, the traffic and transportation network data setups, data points. These are available, right? You use Google Maps, right? And you have population density data as well. So you can create dummy scenarios where you can run, let's say, Monte Carlo simulations throughout this entire dummy simulation. One example that I would give, which is perhaps not very directly related to civil engineering hazards, but the simulation from that was done about pandemics, right? So this is also, again, dummy data. You can create worst case scenarios. You can that is a point to start. Be very careful about the data models that you use, because garbage in is garbage out. Uh, so if you wish to create a starting setup, let's say you want a survey agency to fund a project and conduct a survey for a small community, you need to give them some sort of ground to build on, and that can be the dummy data can help you with that.
All right. With this, I think we can close our talk, and I want to be the first to thank Ramla for this edifying conversation and presentation. And we hope that, and no pun intended, that we can spark a fire in some young women in Honduras as well, so that they can take up the initiative and be able to replicate this really good, really great project that you, this passion project of yours, Women Engineers Pakistan, in other parts of the world, so that one day, like you said, projects like this are no longer necessary. So thank you very much, Ramna, for your participation. And we hope that everyone else can stay tuned to some of the more talks that we have planned in this agenda. We have some very interesting speakers and very interesting topics that will be seen in the wide gamma of engineering subjects that we have at Unitec. So thank you, Ramna.
Thank you so much for having me. And I would reiterate, if anyone is interested, please do get in touch. I would be happy to help. Thank you again for having me.
All right.
Bye.
Thank you.